Alright, now I got some light here. So as promised, here's my short explanation video of the regulator rectifier that I made for my dual overhead cam CB750. You'll notice the base, the foundation of it is a galvanized steel plate that I took out of just a home electrical conduit box. On this side you see my 3 AC rectifiers. The wiring is a little bit difficult to make out from this video. Maybe that helps. So you see each of the 3 rectifiers has 4 pins. One is a positive DC out, one is a negative DC out, and then the 2 are AC inputs for each. Because these are full wave rectifiers or full phase rectifiers, whatever, I'm not an electrical engineer, but from what I am imagining, each post of the AC handles 1/2 of the AC wave. Regardless, each has 2 posts for AC, and you need to bridge those in order to get the correct output. So here's the connector for the alternator. You have your 3 yellows corresponding to your 3 phases, and then your white and your black feeds for the field coil, the rotor. So the 3 phases come out, they break out to each phase gets its own rectifier, and again the 2 AC posts are bridged on each one, and so then you have your positives all come off each, and they get tied together onto one output, which goes to your red-white, which feeds to your battery. The negatives come out, and they just go to ground, your green wire. And that essentially is the rectifying side of the unit. I tied on here onto these. I just soldered them to the posts just because it was easy. A ground on this side and a ground on this side. And the grounds, one of them on this side is just a ground for the case on the regulator. The other is the ground for the alternator, because and this leads me to the other half of this explanation. The stock system on the dual overhead cam CB750 regulates the alternator output by controlling the ground side. So in essence, when the bike is running and on, the field coil is kept hot. The regulator controls the connection to ground. With this regulator, the field coil is modulated or regulated rather through the hot side, the positive side. So the regulator or the coil always has a solid connection to ground, which is through this black wire, which I just tied into my grounds over here, just to keep wiring simple. So what that leads me to is the regulator. So the regulator works on a function of it has to sense the battery voltage in order to know what to do, what to tell the field coil to do in order to control the output for charging. So what you have is you have 4 terminals. This is IASF. From my research, I've seen it said where the terminal labels don't make a difference. However, I find that to be incorrect. The labels do matter, and they correspond. If you have a familiarity with the way charging systems work in general, you have your armature, stator, field, and ignition. So the field is what we're controlling. That's the whole point of the regulator. So the field terminal goes to your white wire on your alternator connector, and that is your regulated output from the regulator module for controlling the system. So that's pretty simple. The armature, I believe, it is your sensing terminal to see what voltage is the battery at. So this needs a connection to a 12-volt positive source. The ignition is the switching terminal to just turn the regulator on and off, tell it, is the bike on or is it not, in order to get the regulator to do its job. So that actually needs a connection to a 12-volt positive through a switched source, i.e. your ignition switch. So that comes in from the black wire on this connector here. That leads to your ignition switch. So that comes in to your ignition, and what I did is just jumped the terminals, the I and the A terminal, because they're both, all they need is a 12-volt source. The I needs it to be switched. A, not necessarily, but I figure it's a double form of safety, to keep the regulator from drawing any unnecessary power, and killing the battery. So that's really it. I set this up so that it doesn't irreversibly modify the wiring system. It all uses stock connectors, just your two basic connectors. There's nothing extra. All of the wiring is kept in this unit. If this was the stock unit, it would be covered in epoxy, and it would just have these two pigtails coming off. So nothing really different. And I found that this system works actually a little better in the sense that it is able to maintain a charge at idle slightly above, or at least breaking even. So there's that slight advantage. I haven't really had a chance to run this too much beyond just testing purposes right yet. I'm still figuring out mounting. This actually does fit where the stock regulator fits. The only difference is that in the stock regulator, because the obviously smaller footprint in terms of width, or depth rather, it sits back closer to the battery, so you have your connectors for your pulsar, your spark units, flasher, all that stuff sitting right in front of it. What I had to do is move that up and over on top of the battery, and this now takes up the entire cavity on that side, which is not a really big deal. All the other stuff that I mentioned fits underneath the seat in between that and the battery comfortably. No real big issues, no modifications. I didn't cut anything, I just moved it. Got rid of a couple brackets that held all the connectors, but those I don't really miss. If anything, I'm saving weight, right? So yeah, for my testing purposes, it was reading 12.7, 12.8 volts at idle, and would go up to 14.6 to, I saw it max out about 14.8 at about 3,000 RPM and up. The regulator doesn't get hot at all. The rectifiers get warm. They definitely get warm. They do not get hot. I have not seen them get hot. Oh, good thing I actually thought of that. These rectifiers actually, on the bottom side of them, there is just it's got a metal face on it. So that's why I have them bolted to this plate. I have some thermal compound that you would use on like a computer heat sink sandwiched in there, and you sock them down tight with a nut and a bolt, and the galvanized plate, which is a nice thick, heavy plate, and maybe the addition of the metal. Like I said, haven't had a chance to test it extensively, but I've run it. I've run it for a good 10-minute period, just testing and making sure it's all good. And they didn't get hot; they got warm. Part numbers. This regulator unit is a BWD a make. The part number that I used is R400P. You might also find it listed as an R400Z. They're the same thing, though. When I was at the parts store, the way I remember to ask for it is the same one that's used on an 80 Ford LTD with a 5.0. My cat's getting in here. Hello. There are other manufacturers. This unit is used in a bajillion cars from like the 70s and 80s, so it really shouldn't be a difficult one to find. These rectifiers, got them right from Radio Shack. Part number 115-1186, something like that, or 215-1186. I'll get them for you later. But it's rated at like 50 volts, 25 amps, sufficiently sized for our puny little charging system. So, yeah, that's it. And I will post some pictures along with this video with some links to the resources that I used to build this, and some clarification diagrams if necessary. A very viable replacement. With the rectifiers were like a few bucks a piece. The wiring, as you can tell, is some speaker wire, some of the stock harness, and some lamp cord. Hey, you know what? It works. It's this proper gauge to handle the voltage and the amperage. All the junctions are soldered. These are crimp-on connectors that I got from Home Depot, and yeah, I could undo any of these and put them right back onto a stock unit if I had one, or just take this whole thing out and buy a new one. The regulator was like $12, I think, from Advance Auto. So I'm into this thing for like $30-35, and it works. And I didn't have to wait for a week and a half for some guy to ship it to me or whatever. And it's modular, so if something does fry, hopefully it's only just like the regulator. Really don't see a rectifier going out on me. Honestly, the biggest thing to go will probably be the field coil, and that won't even be due to this. So, very viable alternative, and easily made. All you need is a soldering iron, a crimping tool, and a pair of wire cutters, and you can build yourself a regulator for a pretty good amount of money, a pretty small amount of money, in about a couple hours. Yeah.